Hey guys, so the biggest problem when it comes to building and scaling your AI influencer is character consistency. You want your character to always have the same face, the same body, and the same features that make that character instantly recognizable. Now, the solution to this problem is that you're going to have to train a LoRA of your character. Now, when it comes to LoRA training, a LoRA is only going to be as good as the data set that's used to train it. All right, so when it comes to preparing a data set for LoRA training, we want to make sure that our data set has our character in diverse situations, be it different lighting, different outfits, different poses, different facial expressions. So if we break it down further, we can achieve all of that if we have three base images. One should be a face close-up, one should be an upper body picture, and one should be a full body shot. And based on these three images, we can generate the rest of the images. Before we get into the whole workflow, let's talk about the models that we're going to use for this. So the base image that we'll generate and the image model that we'll train our character LoRA on is Qwen Image 2512. Why this model? Well, that's because Qwen Image 2512 is the best open source image generation model out there, and it gives quite a good competition to closed source image models as well. And its strong points are human realism and fine details. And you can find this model on Hugging Face. The second model that we're going to be using that's going to do a lot of heavy lifting in our workflow is Qwen Image Edit 2511. So it's not a pure image generation model, it's more of an image editing model. And this is what we're going to be using to generate different variations of our character for our LoRA dataset. Now, the strengths of image edit is character consistency and fine detail. It also has integrated certain LoRAs that the community built for the previous model of Qwen Image Edit, such as lighting LoRAs. So these come baked in the model itself. And another very important LoRA that they've baked into the model is the novel view synthesis, which essentially lets us generate an image of the character from a different angle, which is very important in creating a diverse data set. Another model that we're going to be using is Z-ImageTurbo, not for generating images from scratch, but to upscale and to add realism to skin texture of already existing images that were generated by our Qwen image models. SeedVR2 is another model that we're going to be using. It's a video upscaler, but these days this is one of the best upscaling model for images as well, and it does a great job. All right, let's jump into the workflows now. So first off, don't get intimidated by this workflow. This is a very simple workflow, and I'm going to break it down for you. There are 5 stages, and each stage consists of 2 levels. Level 1 is where we generate the image or we edit the image. Level 2 is always the upscaling part where we use Z-ImageTurbo and SeedVR2 to upscale our images by adding some textures to the skin to make it more realistic and upscaling it to 2K resolution. Let's start with stage 1. This is where we have our Qwen Image 2512 loaded. You can use a lightning LoRA. It's gonna decrease the time it takes to output an image, but I generally prefer to not use it because the quality goes down, at least in my experience, that's how I feel like it. The character that we're going for is an old, wise, strong guy. And focus on the K sampler. We're setting the steps at 40 and the CFG to 4. If you want to use the lightning LoRA, the steps are going to be 4 or 8, depending on the version of the lightning LoRA that you use, and the CFG is going to be 1. So just make sure you understand that. So after the VAE decode node is done, we set the base image via this setter node. And in the level 2 of this, we get the base image right here, and we load our Z-ImageTurbo. Even though Z-ImageTurbo is a diffusion model, we're not using it to generate a completely new image. Instead, we're using it to add more realism, more skin textures to our image. How we're doing this? Well, this is something that's called multi-step upscaling, where you use a diffusion model to add details to an already existing image. If you pay attention to the K sampler here, we're setting the steps to be 11, but we're starting at step 7. We're not starting at step 1. So if we were starting at step 1, it would almost reimagine the whole image. But since we're starting at step 7 and going up till step 11, it uses the existing image and only adds certain characteristics to that image instead of building a new image from scratch. So once we pass the image through our Z-ImageTurbo upscaler, we pass it to our SeedVR2 upscaler. This essentially takes the resolution from 1K to 2K, and we get an upscaled image. So, and once that part is done, we use a setter node. We set it as the upscaled base image, and that's used by stage 2. We get it right here, and then we're going to use Qwen Image edit 2511. So what's happening here is, instead of just generating one image, we're using this prompt line node, and we have 3 different prompts. Each and every prompt is separated by a new line. So this workflow is essentially going to generate a batch of 3 images. Now focus on prompt 2. In the second prompt, we refer image 2. What is image 2? Well, it's this DW pose that we have. Why are we using this? Well, in my experience, I realized that Qwen image models, when you ask them for a full body shot, they produce characters that look short, stocky, and they have a big head. So I went ahead and used this DW pose because Qwen image models, they understand ControlNets, they understand these DW pose images. So if you put them as reference, the model is going to ensure that they follow the structure that's within this DW pose. You can also go ahead and use any other random person who you think is tall. And if you just prompt it to follow the body proportions, it will most reliably do so. But using a DW pose is much better because they've been trained on ControlNets as well. How I got this was, well, I used a pose builder workflow, which is right here. So this is a VNCCS node. Here we can control the pose of a character. We can control their height. We can control their limb lengths. We can control where their limbs are placed. We can basically have complete control over how they look in terms of their pose. And basically it spits out a DW pose, which is done by this node. And I basically ran this before, and I saved in the image. I plugged it back there. So this image is only used by the second prompt, which is for the full body shot. You can also use a lightning LoRA. That's a 4-step or an 8-step. But I would advise against it, as I've noticed that when you do face close-up images with this image edit model, and if you're using a LoRA, I noticed a lot of artifacts within the image, and the skin texture is just weird and doesn't look real. So I decided to not use a lightning LoRA here as well. So the workflow is quite bare bones and quite basic. Here the same thing happens. So once we get the upscaled image from our base model, we plug it in here. The image edit model generates 3 variations of it, and then we set it as reference images. And in the upscaling part, we fetch those reference images and we upscale them using the same workflow as above. We use Z-ImageTurbo, we take it from step 7 till 11, and then we plug it into SeedVR2, which is a video upscaler, but it does a great job at upscaling images as well. And with this, basically then we have 3 images which are upscaled and ready to use for generation of our downstream data set. Now let's run the workflow. We're going to run the first 2 stages first. This is where we'll generate a base image and 3 reference images. That's going to guide our downstream data generation process. So for now, I'm just going to bypass the bottom 3 stages. You just mute them. And here we go. Great. The workflow ran successfully. Now let's look at the output. So our base Qwen image model gave us this old man in the resolution of 1328 by 1328. The resolution which we set using this node. Now we pass that image to our upscaling node where we use Z-ImageTurbo and SeedVR2. And this is what we got. Now it's scaled to a resolution of 2K. And just to compare the output, here we have an image comparing node. If we zoom in, you see the difference? On the right side is the base image that was generated. And on the left side is the upscaled image. Just look at the details, the wrinkles, the eyebrows, the hair, the eye details, the skin texture. Everything's like so much better and realistic now. Now this base image was passed down to our Qwen Image edit models, where we used it to generate 3 reference images. And again, we upscaled them using the same process. And now we have a set of 3 high quality base images where the face is consistent. So just to compare the different versions. This is what Qwen Image Edit 2511 gave us when we asked it to give a full body shot. Looks like a decently well-built tall guy, but when we zoom in, the details are just missing. But due to upscaling, we're able to generate a much better quality image. And third image, let's just see that all as well. Like, amazing quality, very realistic, great. So now that we have generated 3 reference images, we're going to use each image for these 3 stages. This is for face close-ups, which we're going to unmute now. Great. And we're going to do the bottom 2 later on. Great. So here, if you look at the prompt node, we have around 10 different prompts. And this is going to generate 10 different images where the face and his facial features are the point of attention. So we just want to run the third workflow, which is going to comment out the first 2. We don't need them anymore. Okay, so we need to make sure that we don't bypass these nodes because we're setting them up, and then we're just using get nodes everywhere else to pass them in. So just a small pointer. Now that that's fixed, now we can run it. Our third workflow, which focused on generating variations of different expressions, is complete. And now we have different variations of our old man with different expressions. Let's take a quick look. Nice expressions, amazing detail. Yeah, this would be great for training a LoRA. Because the facial details, they're going to get really baked in. And the details are really crisp. Everything looks great. Amazing. So now I'm just going to bypass this workflow as well. And we're going to execute the full body workflow now. All right. I think here we have 20 prompts. And yeah, let's just get this going. Great. So now our full body workflow has also been completed. We generated 20 full body images. Of course, we're going to be selecting some of them, not all of them, based on the quality and the consistency. And now we can progress to our waist up shots workflow. Just going to bypass this workflow and bypass this. Just execute this. Perfect. As you can see, the workflow is now complete. We have generated around 45 images of our character in different settings, different expressions, different clothes, different poses. And of course, we're going to filter it down to around 20 to 30 images from 45. And once that's done, we're going to generate captions for each and every image. And then we're going to proceed on to LoRA training. Now that we have generated all the images that were required for our dataset preparation, and we've filtered those images down to only the select few, now we're going to come to generating captions for each and every one of those images. For this process, we're going to be using a vision language model, Qwen 3 VL to be exact. This model can understand images and it can provide descriptions and captions for that image, which is the perfect use case for generating captions for a LoRA training dataset. It's a very simple workflow. We basically upload our zip folder, which contains our images. It takes in that folder, it passes those images as a list. Now this Qwen VL node is going to process those images and generate texts. And we're basically going to concatenate all those different paragraphs using a new line delimiter. And we're going to process that caption as JSON later on. We'll get to that. But before that, pay special attention to the prompt that we have set for the Qwen VL model. We're asking it to not describe the character's facial features, his body type. Why? Because when we perform the LoRA training, we want our image model to associate all those facial features, that body type, with the trigger word oldie goldie 420x, so that we don't have to prompt his facial features, his body type. We just need to type in this trigger word and the image model will understand what we mean. Other than that, we asked this VL model to provide extreme detail for all the other elements, such as his expressions, his pose, his clothes, the background, the lighting, etc. So let's trigger this and we're good to go. Great. So our batch caption generation workflow is also done. And we have almost 17 final selected images. And we have generated 17 captions. Now, what we need to do is we're going to utilize a little bit of Python scripting. And the final step of dataset preparation for LoRA training is that you need to create a folder. And each image should have its own specific caption text file. And the caption text file and the image file, they both need to share the same name. So we're going to just utilize basic Python scripting for this, and we're going to make it happen. Just going to copy this. I have those scripts pre-written. I'm just going to load it there. Paste it here. Okay. Generated a JSON from that. Cool. Great. So this folder, LoRa dataset.zip, this is our final folder that we're going to use for LoRa training. We're going to be using Ostrich AI toolkit for LoRa training, and we're going to move over to RunPod now. Great. So now we're going to train the actual LoRa, and for that, we need to rent a GPU on the cloud using RunPod. For training an image model like Qwen Image 2512, which is huge, I would recommend going with a heavy card, like something like RTX Pro 6000. This seems to work great for me. Now, once you select it, you need to make a couple of changes. The first is you need to change the template. We're going to use Ostrich AI toolkit for managing our LoRa training. We use the official image, and then we're going to change a couple of things about this. First, we're going to change the password. It's currently set to password. Change it to something that we know. I also recommend increasing the storage capacity in both the container disk and the volume disk, because the models are going to be downloaded and kept here. And I've seen a couple of times my LoRa training crash just because I did not have enough storage here. We're going to use a volume disk, not a network volume. And we just deploy. Great, so now we just open it up. Put in the password that we set in the environment variables. Inside. Now the first thing that we have to do here is create the data set that we're going to run the training on. Just select the entire folder that we had prepared that contains our images and the captions, and we import them all over here. This should get uploaded pretty quickly. Great, so now our dataset is also loaded. Now we just have to create the training job. Or a new job. Okay. We don't need to put in any trigger words here because we already have the trigger word set within our captions. And we're going to be caching the text embeddings to the disk. So we do not need to use the trigger word here. When it comes to the model, we're going to select Qwen Image 2512. Low VRAM, make sure you keep this on. Float 8. I would recommend bringing this down to 6-bit because this is a very heavy model. And if you bring it down from float 8 to 6-bit, that is going to help you a little bit. You can increase the linear rank to 64 or keep it at 32. That's your preference. Data type BF16, that's fine. FP32 is going to be a bit too much, but BF16, let's keep it at that. Should be good. We increase the max step saves to keep to 6. So it's going to save all the LoRA versions from step 1500 up till 3000. Batch size 1. Steps are 3000. Great. We can increase the learning rate to 0.0002. We can change the time step type to sigmoid, or we can keep it to weighted. Completely your choice. I'd go with sigmoid. Very important is to cache the text embeddings. So basically, we cannot use the trigger word and cache text embeddings together. Since we have our trigger word within the captions, caching the text embeddings makes much more sense for us. Right. And go to advanced. We can do differential guidance. It basically helps us speed up the training process a little bit. So you can read about this here. So instead of shooting for the target and landing before it, it tries to shoot ahead of the target and land somewhere between the target and the differential guidance target. So we can try this. I think 3 is fine, whatever they've set. Dataset. We just want it for 1024. Our images, all of our images are of 2K resolution, but when we're going to be using the LoRA, we're mostly just going to be generating a 1024 resolution image, and then we're going to upscale the image to match our resolution. Sample every 250. Great. Yeah, we're just going to leave this as is, whatever this is. So guidance scale here is the CFG that we had in the K sampler, and the sample steps is 25. So generally when we run Qwen Image 2512 on ComfyUI, we set the CFG at 4, but the steps are generally 30 to 40. Ostrich recommends it at 25. I'm just going to leave it at this. When it comes to the sample prompts, this is where, so after every 250 steps, this platform is going to generate a sample of images using the LoRA at that step, which basically we can refer to and make the judgment if the LoRA is good enough for our use case or not. So within the prompt, we need to place our trigger word, and that's it. Yeah, that was our trigger word. And we should be good to go. Great. We just create the job. So when you create the job, it is going to get queued. It will not start on its own. So you just come here and you press on this play button. That should start the job. Starting job, running one job. Great. So this JSON, this holds the entire configuration of our LoRa training that we've set up. After this, it's going to download the Qwen Image 2512 image model from Hugging Face, most likely. After that, it's going to cache the text embeddings on disk, and then it's going to start generating some base images without the LoRa, and then it's going to start the training. And after every 250 steps, it's going to generate a sample of images based on the sample prompts that we had set. All right, I'll see you guys once it's done. All right, so the LoRa training is now complete. It has gone up till 3000 steps. We have saved the last 7 checkpoints, and let's go over the samples and we'll see how the LoRa training improved the quality of the images and the character resemblance. We come over to samples. You see the first row of images, there's no similarity with the character. These samples were generated at step 0. But then after 250 steps, you start seeing some likeness in the character, but not that much. Again, it's a hit or miss. But as it went on, the character recognition started improving. But we also started seeing some problems. Like if we look at this image, there are artifacts in his forehead because the prompt is building a log cabin, and the model basically put the logs in his forehead. So this is an artifact. So basically we can reject LoRa's up till this step. And if we go down, then it improves a bit. Like this picture came out really nice. I can start seeing the resemblance quite heavily. But in the next step, again, it messed it up. We can see the artifacts in his forehead, and it's just not something that we would want. If we go down, you can see it started off as a skinny old guy, but since our old man was a muscular, jacked guy, we can see the muscle tone also increasing on our guy. Like, see here? It looks like a shredded grandpa who also plays guitar. And if we come down, I think the best ones are the last two. At step 2750 and at step 3000. At 3000 is just like perfect. This is just perfect character consistency that we wanted. All of these images, like, you can see the resemblance is just 100% there. The LoRa training came out really well, so we can just go ahead and download the last two LoRa checkpoints, which is going to be the top one. This is the final at step 3000, and we'll also take the LoRa at step 2750. All right, now so to test our LoRa's that we built, I created this very simple workflow. This is nothing but a very basic Qwen Image 2512 workflow where we have included our LoRa's that we downloaded from Ostrus AI toolkit that we ran on RunPod. So basically the model node splits into 2 and plugs into the 2 different LoRa's, and we're using prompt line node, and we're plugging in 3 different nodes so we can compare. And I've run this already. Everything is, the seed is the exact same, the CFG and the steps, everything is the exact same. There's just a difference of the LoRa. And if you come here, you'll see the comparison. The one on the left belongs to 2750, and the one on the right is at step 3000. As you can see, like, it's pretty much there. It's just almost identical. Honestly, I think we can pick either one of these and we'll be fine. Our character did come out very jagged. I like that. Just look at the quality. I mean, it's almost there. You could make a point that the quality of 2750 in this image is much better than one for 3000. But that's something that you're going to have to figure out as you iterate over different images. Well, so to wrap it up, that's it. That's how you create a consistent character LoRa. That's how you generate the data set and you do the LoRa training. I've included all the workflows in the description. If you liked the video, consider subscribing and hitting that thumbs up. I'll see you in the next one. Bye for now.